Welcome back, welcome back, welcome back. I'm Miss Lisa and this is my YouTube channel where I talk about everything that I want to with science and math. And today we're talking about physical science and we're going to talk about chemical bonds. So I brought a little whiteboard to write on and it has a cat on it. It says meow. And as I was looking at this chapter, I realized that I kind of already talked about everything last chapter because I'm too excited and I have to talk about it. I was like, oh, let me tell you about this too. And so a lot of this is going to be a repeat, but I'll not go into too much detail so you're not wasting time going, you already said that, you already said that. I know, I already said that, I already know that. All right, so we learned about the elements. We learned about the periodic table of the elements, that the elements are the Legos. They're the things that can't be broken down any further and still maintain the properties of that element. So a gold atom is yellow and shiny and, conducts heat and electricity, where if you break it down into protons, neutrons, and electrons, they're the same. They don't have that characteristics anymore. Now, these elements can be combined, and when they do, it's called a compound if they have chemical bonds between them. Last time we talked about a mixture, and a mixture is not a compound. It does not have chemical bonds between it, and with a mixture the amounts may vary. So you can, like chocolate milk is my example, you can have chocolate milk with a little chocolate or a lot, it's still chocolate milk and it retains the properties of what makes it up. So you still taste the milk, you still taste the chocolate. With a compound, it's made out of elements. They're chemically bonded. The amounts do not vary. Water is always H2O. If you change it and make it H2O2, you don't have water anymore. You've got hydrogen peroxide. If you drink it in its full strength, you will die. You're like, I've had hydrogen peroxide. You had 3%, not full strength. So compounds have discrete, definite proportions. There's a law, the law of definite proportions. And they are combined into a new substance that does not have the properties of what makes it up. So water is made out of hydrogen and oxygen. At room temperature, oxygen is a flammable gas. At room temperature, hydrogen is an explosive gas. But water at room temperature is neither flammable or explosive nor a gas. It's a liquid that puts fires out. So it has totally new properties once it's combined in the compound. Now, what combines it? Chemical bonds. So what chemical bonds have to come? They come from either sharing or transfer of electrons. And we'll talk about that. We talked about that last time, that if they are transferred, it's ionic bonds. And what holds them together is one becomes positive, one becomes negative, and opposites attract. When they combine, they are neither positive nor negative anymore. They're neutral. So so now they're neutral, they're stable, they're happy, they feel like noble gases. With covalent compounds, they share electrons. And we'll talk more about that. Now, I've already said that water is H2O. So chemical formulas are made by writing the symbol of an element in the definite proportion. So 1 hydrogen, subscripts tell how many, 2 H2O, oxygen. Okay. Next, let's see, chemical formulas, we talked about that. Now, why do they do this? It has to do with energy. It's more stable. I always say that they're happier like this, but then people say, Miss Blackburn, do they really feel happiness? No, they don't. It's all about energy. And so energy is why they do this. I say they all want to be like noble gases because just like people want to be like William and Kate, the Prince and Princess of England, because, their nobility really it has to do with energy. When they have these full outermost electron shells, those are called their valence electrons. When they are full, and the shells, the orbitals are full, then they're more stable and they don't feel the need to react with other elements. And that's what the noble gases. The noble gases either have 2 in the case of hydrogen, and it's in the case of helium, pretend I didn't say that, in the case of helium, in its outermost shell, or 8 in the others, which makes it feel stable. Now, the fact that they want to have 8 electrons in their outermost shell is called the Octet Rule. And the guy who figured it out, he said it's like music. The music scale has 8 notes, it's like music. And everybody was like, no, that's stupid. Chemistry doesn't have anything to do with music. You're dumb. Well, then he died with everybody calling him dumb. And then they went, oh, he was right. So He's vindicated, but I don't know if he knows about it. I hope he does. I hope he's like, ha, I told you I was right. I told you it had to do with music. That 8 is a number that nature likes. Music is natural. All right. Okay. We talked about noble gases. We talked about stability. We talked about energy levels and outermost levels. Now then, let me show you this again. I showed it to you last time. I told you I talked about this last time, but sorry, I didn't realize I was jumping ahead. And I should, because I've taught this before. Okay, so here, this is a little thing that shows the energy levels. And so, like, if you look at lithium. Lithium has 2 electrons in its first energy level, its 1s level. And in its second energy level, called 2s, it has 1. Well, it doesn't like having 1. It wants to have 2. It'd rather have none than have 1. So it loses that one and gets a charge. It lost, electrons are negative. It lost 1 piece of negative, so now it has a charge of +1. Remember, these are our bad parents who try to leave their kids at Walmart and turn them in at the fire station. These are the parents who abandon their children, their little electron children. Okay, over here we have the noble gases, and you can see theirs are full. Helium with its 2 electrons, neon that's got a total of 8 electrons in its outermost shell. Argon, it's got 8 in its outermost shell. Okay, but now if we look here at fluorine, it's missing 1. If it had 1 more, it would feel like neon, but it's missing 1. So it has a charge. It has no charge to start off with, but it decides it needs to steal an electron. So so when lithium abandons its baby and leaves it, fluorine just sweeps right in, whoop, and gets that baby electron and says, you are my baby electron now. Well, now because fluorine has added 1 piece of negative to it, it has a charge of -1, where lithium has a charge of +1, so they get together because opposites attract, and they become lithium fluoride. Dun-dun-dun, an ionic compound. And these ionic compounds make crystal lattice. They're very strong, they're very stable, they're salts, and they're all happy now. Now, over here on the periodic table, where you have carbon to feel stable would have to steal 4 electrons, and that's a whole lot. So it doesn't usually do that. They found out now that it can do it. I was reading the research about it, and there is a carbon ion, and they're using it for something. I read in the research to treat some kind of cancer. I think that's what it was. But anyway, they've discovered it. They're using it in medicine, but I can't remember what, but you can Google it. I'm sure it was something that came out last year, I think. But what it does instead is that's just too many. It usually can't do that. So what it does instead is it works out sharing arrangements. So it wants to get 4. And hydrogen over here wants to lose 1 or give it away. So hydrogen will bond with carbon and they'll share. And so that's 1 down. So how many hydrogens does carbon want to work this arrangement out with? 4. So carbon will be surrounded by 4 hydrogens in a sharing arrangement, making a special shape called a tetrahedron, which is the basis of life. That and water, carbon and water, is why we can have life on this planet. It's because carbon is extremely versatile. The way it will make all these sharing, it's called organic chemistry. These are hydrocarbons, and there are just so many different compounds it can make. That millions of compounds, and there's a whole branch of chemistry devoted to it called organic chemistry. And I kind of like it. I took it in college for a year, and I like it because it's just, you see these patterns of what happens, and it's interesting. My son is getting his doctorate in chemistry, and he's probably going to go with something organic too, because he likes it too. He says it's like a sliding puzzle, figuring out how it all fits. And then you do it, and it's real practical, because carbon is everything that you love. It's people, it's food, it's medicine, it's things are made out of it. So it is a building. It's a building element that you can make new stuff with, which is great. You can have big impacts with it. All right, so they want to fill up, and then they reach stability, either by sharing or by transfer, covalent or ionic, okay? We talked about that. We talked about ionic now, and we talked about the 0 once it gets together. Now, sometimes elements can share more than one. So let me show you. Oxygen is right here, and it wants 2 electrons more, because see, it's 2 hops over to the noble gas, so it wants 2 more electrons. So it can work that out by getting 2 hydrogens, and then it's got water, H2O, or it can actually bond to itself. It will get another oxygen, and each one shares their 2 extra that they've got in their outermost level, and they'll make 2 bonds. So instead of the 2 atoms just sharing, them each giving 1 electron to sharing, the 2 electrons make the covalent bond, they'll each give 2 electrons, and it makes what's called a double bond. And they can even, carbon can do 3. They could share 3 with another carbon, and it's a triple bond. You would think these bonds are stronger, but actually that's where the bonds break and things get added to them, which you can learn more when you take organic and about why that is. All right, so you can have multiple bonds. Also, I told you last time that they only share equally if they're the same. So when oxygen shares with oxygen, they share those electrons absolutely evenly. And if you remember, I said these are our divorced parents who have custody arrangements. And just like most of you guys, if your parents are divorced or you know somebody who is, you usually don't have exactly equal custody arrangements. You don't spend Monday with mom and Tuesday with dad and Wednesday with mom and Thursday with dad. That just drive anybody crazy unless mom and dad live next door to each other and the kid could just run back and forth. But it's usually unequal in real custody arrangements, and it is also in sharing. And it's whichever element has a property called electronegativity. If it's got more, that means it has a stronger ability to attract electrons to itself, and it gets the electron most of the time. That causes unequal bonds that have, it's not like when ions transfer electrons and they become positive and negative, but it can be just a little positive and negative. It's called a partial charge, a partial positive or negative charge, and it gives atoms, instead of being the same, compounds, instead of being the same all around, they'll have a positive end and negative end, and water has that. And if it didn't, we would have no life on this planet, because that is what is used for trees to be able to get water out of the soil and have photosynthesis so we can have oxygen and food. It's one of the things that contribute to ponds not freezing from the bottom up, to the water density. It makes water the universal solvent. All these things, life is based on the fact that water makes this polar bond. Life is also based on the fact that carbon makes its tetrahedral shape when it bonds. So those are 2 very important things that you can learn lots more in chemistry. In chemistry, in a normal semester, I like to spend a whole chapter, a whole unit on water, and a whole 1 or 2 on carbon. But right now we have the COVID, and we keep losing days, and so I might not get to do as much as I want to. But it's there. Most chemistry books have like a whole chapter on water and a couple of chapters on carbon. Okay, so they pull on that, polar or non-polar, we talked about that. You can remember that polar is the one that has a positive and negative end, because on the Earth, the ends are the poles, North Pole and South Pole. So if it has ends, then it has a positive and negative, and it's polar. If it's the same all over, it's non-polar. And it turns out there's a lot of chemistry based on this, that like a Sharpie is non-polar, and it won't come off with water. But a water-based marker is polar, and so water can get rid of it. It can dissolve it. So and like dry cleaning fluid is non-polar, where regular, wash it in your washing machine, is polar. So like dissolves like, and there's a lot more to this chemistry than what we're really going to get into. Now, so binary ionic compounds, we already talked about that if it's ionic, that you get something from a metal that becomes positively charged, and a non-metal that is negatively charged, and then they work it out, and they'll work it out in a ratio where it is neutral. So there are some compounds like sodium chloride where it's one of each, or lithium fluoride where it's one of each. But you can also have lithium oxide, and it would take 2 lithiums for the 1 oxygen. Notice that I didn't call it lithium oxygen. When you name these things, you put the metal first and the non-metal second. The metal becomes positive, so it's called a cation. And you can remember that because cats are wonderful, sweet, positive creatures. And I don't want to hear anything different because otherwise you won't remember it. The non-metal becomes negative, and it's called an anion, and it goes second in the name, so it's lithium oxide. And you change the ending to "ide," lithium oxide, sodium fluoride, sodium chloride. And you can remember that the anions are negative because it almost sounds like ant ion. There's no T, but it almost sounds like it. And here in Georgia, we have fire ants, and they will bite you, and they are terrible. So we might not agree about if cats are positive creatures, but we can all agree that fire ants are negative creatures. We hate fire ants. There's funny Amtrak commercials about blowing them up. All right. Let's see, there's something else I want to tell you about that. Writing formulas. You have to, okay, so lithium loses 1 electron because it's in the first column. Things in the second column lose 2 electrons. You skip the ones that are down shorter and you go over to the other side, and that next column that's got aluminum in them, they lose 3 electrons. They're all cations because they're positive and they go first, okay? On the other side, it's how many steps away they are from noble gases lets you know how many they gain. So the halogens, chlorine, fluorine, bromine, they are 1 step away from noble gases, so they need to gain 1 electron to become -1. The ones next to them, -2, the ones next to them, -3, and the ones in the middle, carbon, we usually skip that because they do weird stuff. They usually don't make ionic compounds. I already told you. They usually make covalent compounds where they share, okay? So, so when you write the formula, say if you're writing lithium oxide, lithium loses 1 electron, oxygen gains 2. How you know the ratio, like water is H2O, is you switch those numbers. Let me get my little board here. Where'd I put it? Board. I had a board. Where'd I put it? Doop, doop, doop. This makes really good TV, isn't it? Where the teacher loses their board. I found it. Okay. So let me show you how this works. So doop, doop, doop. It's more fun with sound effects. Okay. So lithium becomes +1. Oxygen is -2. It needs to gain 2. It's 2 hops away from the noble gases. When you write this formula, it's cool to write just plus and not +1 because, you know, we're nerds and we like little shortcuts. It's like the understood 1 in math. We like to have an understood 1 too in science. Okay, so when you write its formula, I say it's crisscross applesauce. So you write Li, and then you take this 2 up here and you write it as a subscript. And the O gets that 1, but we don't write it. So it's Li 2O. And that makes it neutral because if I have 2 lithiums, then it's +1 +1 -2. And if you did that mathematically, it would be equal to 0. So it always makes it 0. So you cross, if it's ionic, you just cross those charges. Now, there's a thing that makes it a little bit more complicated, and your book calls it complex ions. I call them polyatomic ions. And what it is, there are certain atoms that they will bond covalently, but then together they will be an ion and gain or lose electrons, and as a group they will go into an ionic bond. So they share electrons among themselves, but then as a little lump they act like an ion and combine with this other side. So one is hydroxide. You've probably heard of hydroxide. Sodium hydroxide is Li, so that's OH. And it gets a special name because it is polyatomic. Oxygen and hydrogen work together and become an ion. that gains 1 electron and has a charge of -1. And that it can get together with sodium, which loses an electron, is +1, and becomes sodium hydroxide, which is the science name for lye. If you've ever heard of lye soap, it's made out of sodium hydroxide. So that's polyatomic ions. They work together. When you take chemistry as a full class, you'll learn more about how to write things with them. But that's just enough for you now to know that it exists. Now, sometimes in the crystal lattice, remember how we learned solids or crystal lattices and stuff? Sometimes you have a chemical where it's all set into a crystal lattice, but water is a tiny little molecule, and sometimes it can go in and fill in the spaces. It's not bound in the crystal lattice, but it just fills in spaces in it. And this is called a hydrate. So there are certain compounds that water fills into the crystal lattice, and it's a hydrate. I do a lab with my students in chemistry where I think it's copper sulfate that we use. They're blue crystals, and you heat them up and they turn white gray kind of as you drive the water out of them, and they kind of pop because as that water is becoming steam, it busts out of the crystals. It's very dramatic. You have to put the watch glass on it so you don't get popped by hot blue rocks popping at you, but it's pretty fun. And then you can weigh it, and it will weigh less because the water evaporated away. And then you take a dropper and you put water back on it, and ching, it turns blue again. So you can look for some hydrate videos on YouTube with your mom. Make sure you're not going to end up seeing something bad. But there should be some out there, people drying out hydrates. They're fun. It's a fun little lab. We'll do it this time in my chemistry classes I'm teaching. All right. We talked about that. Okay, now we remember that these are where I talked about naming them. That was lithium oxide, sodium fluoride, stannous fluoride. That's in toothpaste a lot of times. Those are all ionic. You say the cation first, then the anion with "ide," unless one of those is a polyatomic ion, and then you say their polyatomic ion name, like sodium hydroxide. You say it's polyatomic ion name. Now. But what about if they share? If they share, it's a different naming system that uses prefixes. So, let me think of one. I'm trying not to get too detailed with this because this is kind of detailed. So anyway, you use prefixes, and the prefixes are mono, di, tri, tetra, penta. Hexa is 6, hepta, octa, nona, deca. So those are prefixes you use to name some of these if they are sharing electrons instead of transferring. The reason why I kind of hesitate with this is because if it's carbon that is doing the sharing, there's more to it. And you also have to learn not only the prefixes, but you have to learn the roots of how many carbon atoms it is. And that's where you get those chemical names like, you probably heard of propane. Prop is 3, means 3 carbons, and ane means it's all single bonded. So propane, like in your gas grill, is made out of 3 carbons, all single bonds, and the ane means they're all single bonded. So like butane, you've heard of that, in a butane lighter, like, you know, big lighter that to light your fireplace with and stuff. Oops, that was the board. Bute means 4. So there's also prefixes and roots, but you don't have to know about the roots in this chapter. I probably just taught you something ahead, but anyway, when you get to chemistry, especially organic chemistry, you'll learn more about the prefixes, roots, and suffixes that go with covalent compounds. All right, science is great. Come back next time and we'll learn something else. Like, share, subscribe.